Perfect.
Cool. Hi, everyone. My name is Yixiao. I'm a PhD student at UMass Amherst. Thank you so much for having me. It's a pleasure to be here and take part in this wonderful opportunity. So today I'll be presenting our work, BearCUBs, a benchmark for computer using web agents. First, what are computer using agents? I believe everyone has a rough idea now at this point, but in short, they are AI agents designed to operate your computer, just like a human would. And several companies have released their own versions. For example, Anthropic introduced one last year, claiming it could use a computer much like a human user. And similarly, OpenAI released Operator in January this year and claimed that the agent can see and interact with a browser. And importantly, the agent is claimed to have the ability to self-correct when it makes a mistake. Now the question is whether these claims are valid. To answer this question, we created BearCUBs. But one might ask, aren't there already benchmarks for agents, as we've seen in previous presentations? So the answer is yes, there are existing benchmarks for agents, but BearCUBs complements them by filling key gaps. So first of all, some of the benchmarks rely on synthetic and simulated environments. But even when agents perform well on those benchmarks, it remains unclear whether the agents can handle the complexity and unpredictability of the real-time web. And second, some of the benchmarks are becoming less challenging for agents. For example, Operator achieves 87% accuracy on Web Voyager and 58% accuracy on Web Arena, where human accuracy is only 78.2%. And also, some of the benchmarks test a restricted set of capabilities of agents, such as map navigation, or the tasks can be solved by looking at HTML sources. So what we want to do in BearCUBs is we want to see whether an agent is able to combine all the skills they learn from different, they perform well on different benchmarks and apply them in real world web. So to complement existing benchmarks, we created BearCUBs. And BearCUBs is a dataset with 111 questions. 56 of them are text-based and 55 of them are multimodal. And text-based questions can be answered by interacting only with the textual content on the website. And multimodal questions require the agent to engage with tasks like watching a video, playing a mini web game, or navigating a virtual or 3D tour. So to solve the questions in BearCUBs, an agent must visit at least 108 distinct top-level URLs across the web. This ensures that the dataset cannot be solved by simply training an agent on a small fixed set of websites. And these are only top-level URLs. There are much more web pages that an agent has to visit to solve the questions. And on average, solving a question requires 6 steps and visiting 3.4 web pages. Let me show you an example question from BearCUBs. Here, the task gives very clear instructions, and most of our question in BearCUBs gives very clear instruction. Here it says, the blog page of AI2's own OCR website contains a section that allows the user to compare OCR tools on a historical document. What is the exact text written below the horizontal line in the right margin of this document? So just by reading this question, you have a very clear, as humans, we have a very clear idea of how to find the final answer. So here is a video of the expected trajectory of an agent and the correct answer. So first of all, of course, we need to find the web page. And luckily, the first returned result is the correct one. And we go down to find the interactive tool comparison section, click on the historical document. And what you see is I'm trying to find the right margin and confirm that there's only one horizontal line. And at the end, we found the answer below the horizontal line here. Straightforward and clear. Okay. So that was an overview of our dataset BearCUBs. Now we want to know how well human baselines and agents perform on it. To answer this question, we conducted human evaluation and tested some baselines. Basically, GPT-4o and DeepSeek R1 with and without Google search retrieval. And also we evaluated Perplexity Sonar Pro model, which is a search augmented language model. We also benchmarked several deep research agents, including the ones here in the middle box that are good at web search, but have very limited or just limited multimodal interaction abilities. And finally, we tested the computer using agents here in the rightmost box. These are supposed to be able to do anything on a computer, as their creators claim. Now for the results. The plot we see here, the x-axis shows, for example, perfect accuracy, human accuracy, and the performance of various models and agents. And the y-axis here presents the corresponding counts of correctly answered questions. So what we are looking at here right now is the bar of perfect accuracy on BearCUBs. The blue part here is for the correctly answered text-based question. You see we have 56 here, and there are, this is the multimodal questions. There are 55 of them. So this is the bar, how the bar should look like if the agent or human answer all the question correctly. Now let's look at the human performance. Human got in total 94 out of 111 questions correct, achieving about 85% accuracy. And this shows that the data set is manageable, but it still presents a meaningful challenge. And on this slide now is the performance of the baseline models. We see that their accuracy is very low, meaning BearCUBs is adversarial to zero-shot prompting, large language model augmented with Google search, as well as the advanced search augmented Perplexity model here. So this ensures the quality of BearCUBs and ensures that this data set is really for computer using agent. Now turning to the agent first type here, this slide shows the accuracy result for deep research agents from Grok, they call it deep search, and OpenAI deep research, as well as Google deep research. While they're designed to retrieve internet text, their poor performance on even the text-only questions here in blue suggests that they struggle with anything not presented as plain web page text. Finally, we come to the results of the computer using agents. So although their creators claim that the agents can use a computer just like human, but the results do not support this. Look at the 3 bars here. The performance even worse than OpenAI's deep research here. So the results are disappointing, but at the same time, it's important for us to remember how rapidly AI is advancing today, as shown by the result from this ChatGPT agent, a new agent released last month by OpenAI. So ChatGPT agent not only outperforms all previous computer using agents, but also comes remarkably much closer to human performance, making a significant leap forward. It not only matches and surpasses the performance, the text retrieval capabilities of deep research, but also shows a major improvement in multimodal abilities over OpenAI's operator. And it is reasonable to expect that an agent will soon emerge that not only surpasses human performance, but also achieve near perfect accuracy on our data set, which is exciting. But at the same time, despite their strong performance or the strong performance of ChatGPT agent, it still has notable limitations. And some of the limitations of ChatGPT agent exist in early agents as well. So first of all, there remains significant room for improvement in the agent's interaction abilities. Here we will watch a video showing how ChatGPT agent handled a question involving FBI statistics. The question asks, according to FBI data, which racial group accounted for the highest number of homicide offenders in Massachusetts between 2017 and 2019? So for the sake of time, I will jump through the video, but what we see here is that the agent very quickly, not pretty quickly, found the correct website for the data set. But you see here, from here already, it starts struggling with selecting the correct year from the drop-down list. Here it should select 2017, but it selects 2018, and the struggling goes on. Here, it tried to correct the selection, but struggling. Now the correct option shows here, but it misclicked it. It clicked outside the list, so the list disappeared. And eventually it decided to give up on this thing and go on to select the year for the two thing, and it did it correctly. Then it comes back to this list, missed it again. Oh my God. Okay, now it's got the correct year. Now it moves on to homicide and eventually location. But after that, what all you need to do is just to find the correct plot to see the correct answer. But then what the agent is doing here is abandon the correct website and goes to I don't even know what this website is, to search for the results, but of course it's not the correct website, so it abandoned this one as well, and then come back to the original website. But at the end, after 45 minutes, although the video here only shows 8 minutes, after 48 minutes, the agent still ongoing and then not able to return us an answer. Okay. And then let's move on to the next limitation. The next limitation we saw when we were benchmarking the agent was chaotic action trajectories. I have several examples here on the same question. The question here is, what is the common name of the tree with the largest diameter between building and building at UMass Amherst? And what we see here, deep research, we didn't really expect it to do this question, but still it's interesting to look at how it's struggling, kind of. So here we see OpenAI Deep Research browse numerous irrelevant websites. Among the 46 logged top-level URLs, by the way, they only tell us what top-level URLs they visited, no concrete web pages. So among the 46 visited websites, they duplicated the top URLs, and only 8 of them were distinct, indicating inefficient and repetitive exploration. And its inefficiency is also evident in its repeated actions that makes no meaningful progress, as we'll see in this video of OpenAI's operator, which is a computer using agent, on the same tree question. So not surprising, it found the correct website quickly. And what you all need to do is to find the building on the map and find the biggest circle there. The circle size means the size of the tree. But it tried to interact with the website, but not very successful. It tried to find other resources, but still coming back to this. And finally, it found some campus map of UMass, but you see what it's doing here. It's zooming in, zooming out for a really long time. I would just skip it. It was very boring to see this when we were benchmarking the agent. Eventually, it comes back to the interactive map, but still the same problem, zooming too much, zooming out. Basically, it's not able to do the task, and eventually it didn't return us an answer. So you might think, okay, that was operator. You might think ChatGPT agent can do this better, but the answer is no. The same question here, what is the common name of the tree in this location at UMass Amherst? Okay, this is looks like the correct web page, but somehow it went to another web page which does not give you the correct answer. And it stays on this website for a really long time. Try to interact with it. I'll just skip a few seconds. This is still the round map. It's dueling on it. Not very helpful. Still working on this, but that's not the correct source. I think this is the moment yes, this is the correct website again, and then it goes into the map finally. But in the rest of this video, it's not really trying to interact with the map. So eventually, this time at least it returns us an answer, but the answer is a wrong one. The correct answer, I forgot the name of the correct answer, but here it says it's London plane tree, and the tone of the text here is pretty confident. So it's confidently wrong. Okay, that was the chaotic and inefficient action trajectories. Now the last significant limitation of the agent that we observe while we were benchmarking the agents is that they often rely on low credible sources, which either does not contain the correct answer or makes their answers less trustworthy. And as a reminder, the majority of the question in BearCUBs specify the expected source. So you just follow the question, you should be able to find the answer. But here in this example, the question asks what the transcription of a letter is in a language, and it specifies the source of the answer, and the answer should be from this book in green here. But instead of looking into the book, which is available online, and OpenAI's operator indeed found this book and opened it, but eventually it avoided reading the book, but found an answer from a website called Omniblog. And at the end, it did not read the correct book and also did not return the correct answer. So these are the main limitations we found during benchmarking process. There are other limitations that vary agent by agent, but for the sake of time, I will not going over them one by one. So if you're interested, please read our paper. It should be a fun paper to read. So to summarize, we introduced BearCUBs. It's meant to be a data set that evaluates the agent's ability to combine all different skills in navigating web or using computer. And it reviews key gaps in current agent performance. So for the future, we need to not just close but surpass human agent gap by improving grounding, citation, and step-by-step reasoning. And there are some key steps towards that goal. And first, agents must get better at multimodal control, maybe not even multimodal, maybe just the item selection from a drop-down list, but also like video control, navigating web pages, maps, captcha, etc. And second, the agents really need smarter retrieval. They must identify relevant sources and justify their uses. Stop visiting irrelevant sources again and again. And lastly, we also need transparent, self-verifying agents that can explain their outputs. So as a result, we need good benchmarks and methods to evaluate the improvement made by agents. I want to briefly highlight some future directions at a very high level. First, while it's important to raise the bar with new benchmarks, we shouldn't discard existing ones. Many agents are still far from mastering them. And second, we should build more specialized benchmarks for specific agent skills. I believe there are already a lot of them, like web game playing, captcha solving, efficient retrieval, detailed reporting, and most importantly, multilingual tasks to support global users. And lastly, we need to go beyond answer correctness. Let's evaluate how agents make decisions and, for example, what pages they select, how they browse sources, and how they reason. And that's the key to diagnosing failure and driving improvement. And that concludes my presentation. Thank you.